So hopefully this is an update for many of you. I've spoken to CITRIS groups on this topic in the past, and when I started giving these talks, it was about really the vision for why you needed technology for developing countries, new technology, and I still believe in that vision, but the reason I was giving that talk is because I didn't actually have any results. So all I could talk about was what was possible. So today I won't be talking about why we should be doing this so much, but I will be talking about results. Because after 3 years now, I'm happy to say we actually have some results, and they're pretty compelling. So this is the TIER project, which I lead. It's multidisciplinary with groups from many parts of the campus, including particular EECS, but also many different humanities and social sciences are represented. We have mostly NSF funding, but also funding from Intel and Microsoft, Infineon, and Vodafone, some of whom are here. Thank you. And in particular, our basic premise is that we need to create new options for developing countries in what they can do with technology. Historically, technology is something that is simply comes from the quote-unquote first world, and if it's great, like a cell phone, and it happens to work for you, you can use it. But if it doesn't fit local needs, there's really no way to bridge that gap. So what we try to do is take a high-tech Silicon Valley-style eye to the problems and see if we can address the problems directly with technology as one part of the solution. To do that, of course, you have to go to these places. So most of our work is in India, but we actually have work in several other countries as well. And our basic approach is simply you go there and you try to design with local folks and implement with local folks solutions that are appropriate. And you really have to do this on a pretty fine-grained basis for a variety of reasons. We try to go back every 6 months or more. And you have to kind of deliver every 6 months or more because, frankly, when you go to a developing country and say, I have all these great technologies I think you should use, they're reasonably skeptical. I mean, there's been a long history of people dropping into countries with great promises and little delivery. And so the ground is tainted, and because of that, what we end up doing is try to deliver something small in the first 6 months, right, as a kind of good faith effort to get us started. So the research agenda is quite broad. I won't go through all of this, but it's just a picture of some of the things. Today I'll talk a little bit about telemedicine and rural connectivity. I might get to education and literacy, although I'm going to try to get us back on schedule also. And we also have work in power, including solar power, which I won't talk about, but it's certainly complementary to the many things that Paul just discussed. This is kind of our basic result, and I'll explain what it means. But one of our goals is to get rural connectivity using low-cost Wi-Fi. So one way to do that is to take regular Wi-Fi that's cheap and get it to work over very long distances. This is the same Wi-Fi that you use in your laptop or in Starbucks or McDonald's. And the red line kind of represents what kind of bandwidth you can get, bandwidth on the vertical axis and distance, long distances. So, this N1, 300,000, that's 300 kilometers. All right, so can you get 300 kilometers? We're going to find out in January. We're going to go to Venezuela and try a 300-kilometer link. If we do, it will be the world record. The blue line is what we're getting in simulation on our actual modified Wi-Fi. I can say that the simulated numbers are quite accurate as far as we can test them. Our longest link so far is about 60 kilometers. So we can go using regular Wi-Fi without power amplifiers, using off-the-shelf regular Wi-Fi cards, 60 kilometers at high bandwidth. So that's an important technical contribution. I'll show you what that means for telemedicine in a minute. This is kind of a summary of our best results, but essentially we have links in many countries, in particular India and Berkeley and Ghana, but we also just set up stuff in Guinea-Bissau for community radio. Our longest links are about 60 kilometers right now. Bandwidth is typically 4 to 6 megabits per second, but it can be as high as 18, we believe, going forward. It's very low power, which means that we can use a single solar panel to power these radios. That's very important. And the cost is low, mostly because the cost of the high-volume Wi-Fi parts is low. So the main result we have using this technology is rural telemedicine with the Yerevan Eye Hospital. This is a hospital in southern India. It's actually 5 hospitals in the state of Tamil Nadu. And they understand their customer base quite well. And one thing they've realized is that the limiting factor for their hospital is the distance people can walk to get to the hospital. So they have good patient coverage within about 15 to 20 kilometers. And outside that range, they simply don't get many patients because it's too far to walk. And walking has a bunch of problems. The obvious one is the distance, but also means opportunity cost due to lost income if you have to travel or take transportation, assuming you can afford transportation. Typically, if you have vision problems, you have to take someone with you, so you have 2 lost incomes for that period. And if you know a little bit about India, you might also realize that India government agencies have this problem that you go to the government office and they may tell you to come back the next day. Right? So there's no guarantee that when you get to this location you'll actually get any eye care. Right? So it's very important. We'll see when we do the video conference, one of the things that it provides is simply assurance that if you actually go to the hospital for treatment, we'll give you treatment. And by the way, it's free. So there's lots of need for dealing with blindness, what they call needless blindness. These are people that are suffering eye conditions that are completely preventable. The main causes are cataracts, but also glaucoma and diabetes. Most of this blindness is treatable, and most of it's in rural areas, and most of the people in rural areas, only about 7% get care. So there's a large group of untreated vision problems that are preventable. I should also mention that we've found, the hospital has found, that if you can treat, for say, cataracts, 85% of the people that get treated actually return to income generation. So in fact, it's pretty important for the economy that you get people back to work. Cataracts are the #2 disability in developing countries. So the goal is to build vision centers. What you see in this one is a one-room vision center with our little long-distance Wi-Fi link on top. It has an antenna on top, and that little white box is actually a Linux router with the Wi-Fi card inside. And that's what a typical deployment looks like. This is a map of the actual deployment. The hospital's in the middle. Each of those green lines is a link. They vary in length from about 10 to 15 kilometers. You notice that some of the links have 2 steps. Those are called multi-hop networks, and you can, in fact, use multiple hops to get to locations that are either around a hill or otherwise hard to get to. This is a typical vision center. It's always one room. It has 2 pieces of equipment, which is the PC, which has a webcam and a microphone, and it has the slit-eye lens. There's one staff person who can think of essentially as a lightly trained nurse. She is the nurse, but she's also the administrator of the center, and she's also the pharmacist. So if the diagnosis is antibiotics, she'll actually dispense antibiotics. She's typically a local village girl, which is important because she speaks the local dialect. And she may go to the hospital for training for about 3 to 6 months, but she's not trained beyond that. So we've been running this for about a year now, using the centers around this one hospital, and I'm happy to say we're treating about 2,000 patients per month. So these are real patients using the video conferencing. Pretty even distribution of male and female patients. And I think one thing that's interesting is about 10% of the patients actually have a serious eye condition, meaning cataracts or glaucoma or diabetic retinopathy. So about 10% are being referred to the hospital for surgery. So the value of the vision center, essentially what's going on here is essentially just a video conference between the doctor and the patient, although it's a high-quality video conference, and you can definitely see facial expressions and it's a quality experience. The patients call it TV. I can see the doctor on TV is their view of the system. We actually thought we would do other things, such as sending JPEGs and vitals and things like that over the network. It turns out none of that's necessary. The video conference is the thing that matters because if the patient hears something from the doctor, they'll take it seriously. In particular, if they get a little card that says, oh, you need cataract surgery, here's a card, take this to the hospital, you'll get cataract surgery for free. It turns out the card is unnecessary. They would get cataract surgery for free anyway, but the card gives them some reassurance that they're being taken seriously. Right? So it's for the patients, not for the system. So 10% is a remarkable number because if we're seeing 2,000 patients a month, that means a significant number of people already that are getting significant improvements in vision. So it's somewhere around 200 people per month are achieving significant vision improvement, such as cataract surgery or glaucoma treatment through this process. Another thing I want to point out is that there actually is revenue here. It's not a lot. It's about $460 a month. That may strike you as insignificant, but in fact it's enough to make it sustainable, which I'll talk about on the next slide. What's the revenue come from? Well, the big one is actually the sale of eyeglasses, but there's a few other things too. The fees are not that big. It's about 25 cents to go, although what's interesting is it's 25 cents for 7 visits. Why is that? Well, because if they make you pay per visit, you won't do your follow-ups. So you're prepaying for your follow-ups essentially as a way to encourage people to go, because the follow-ups are actually pretty important, and historically people aren't going to their follow-ups, so you need to encourage that. So you're only getting about $16 a day in income. So is that enough, right? Because this isn't going to work, at least I would argue it's not going to work well if these centers are a money-losing proposition. So we want them to be financially sustainable. So we can estimate that. There's a setup cost. You have to get the space and the PC and the link. That's something on the order of less than $10,000. There's an operating cost, which is about $150 a month. That includes mostly the staff cost, but also the electricity. You have to pay the nurse and the electricity, and maybe some rent. Can you break even? Yes, about 2.5 years is our very early guess. So we don't have a lot of data yet, but it looks like even at $16 a day, because the operating cost is lower than the monthly revenue, and because the capital cost is not that high, you can get this to break even in a reasonable amount of time. So we'll know more. But based on this, the hospital has decided that, in fact, it's close enough to break even for them, and they're going to build 50 centers, of which they've got capital funding lined up for, I think, 24 more, which they'll do in the next 18 months. Assuming you get to 50 vision centers, it's about 10,000 patients per center per year, so about 500,000 patients would get examined using the system at that scale. And then this is just for the 5 hospitals. So in fact, if you scale this up to the rest of India, which again is quite achievable, I think, is a reasonable kind of decade goal, you should be able to treat most of the needless blindness in India using this approach. And the hope, of course, is if you can treat 500,000 patients in the 10% number stays, that's 50,000 people that are going to have significant life-changing vision improvement, including new income generation per year. These are just some of the patients. I point them out just to remind people that this is actually not a lab. This is real patients whose livelihood depends on eye treatment. The guy in the middle actually has had cataracts for 7 years. We asked him, well, why didn't you go to the hospital? And he said, well, I didn't know if I'd get treated. It seemed hard to do. It's far away. Right now, the vision center is here. He's gotten treated, and it's a completely different life. Good. We have a little bit of time. Another topic I'll pick on a little bit, in part because we have some of the posters represented here. So there will be a poster on the Aravind work. There will also be posters on games, which is the second bullet on this slide, and also a multiple mice demo, multiple mice poster. So just real briefly, this kind of get the feeling of some of these projects. The multiple mice per PC project is really quite clever. It just comes to the observation, if you look at PCs in schools, what we found is that it's typically 5 to 10 children using the same PC. That's because there aren't enough PCs, so therefore you have to have a lot of users per PC. Of course, PCs weren't designed for this. So what we tried is, well, what if we give each student their own mouse? Does that improve the learning experience? The reasons that think it would simply are that all the students are now engaged, and if you're engaged, you're more likely to learn. The short answer is, early results are we are seeing better education, particularly for boys. This is primary education, when each boy has his own mouse. For girls, it seems to matter less, and we can figure out why that is. I have some guesses, but no hard evidence. We also have some evidence that computers in schools lead to lower attrition, that the parents value the symbolic value of the computer regardless of its educational value. Right? Now, that may not be sustainable. If it has no educational value, presumably they'll value it less in the future. But in part because of the success of the IT industry in India, almost all parents have a high value of computing and view that as a reason for students to go to school. And it looks like the attrition rates are lower in schools that have PCs, although, again, very early result. English as a second language, it turns out is a very important part of education. It's the part of education that's actually most in demand. So if you ask a parent in India, what are your criteria for what school you might pick, English is probably the #1 criteria. Computers actually would be a high criteria also, it looks like. We haven't asked them that. But it's pretty clear English, primary education in English is the #1 criteria for school selection. So, in fact, you can even argue that English language literacy or knowledge is, in some sense, what determines what class you're in, effectively. That English is the ticket to being middle class or above. So what we're looking at is how can we do a better job of teaching English as a second language using cell phones, in part because the cell phones are quite present, and in part because they're a good immersive environment that might be more effective than just the formal education process for learning English. So we'll have a poster on that. Actually using games, because games tend to have a high, students are willing to pay attention to games. So we're trying to find the magic games that are fun to play, that teach English well enough that kids will continue to use them for an extended period of time. And finally, we're doing a lot of work on speech recognition for languages other than English as a way to deal with illiterate or semi-literate populations, and also as a way, frankly, to help preserve some of the 6,000 languages that are in use on this planet that are nowhere close to having regular speech recognition. So all of the work in speech recognition so far has essentially been on a few languages, such as English, and it's, therefore they don't apply to most speakers in the world. So we're looking at ways we can do language recognition or speech recognition that is not only speaker independent, so it will work with different speakers, but is in some sense language independent, so that it will work with many different languages. And the trick we're going to play there is, of course, that we're not going to be able to do things like dictation or translation. Those require deep understanding of the language. But if you want to have an interactive session, such as deciding what's the price of a particular crop, that kind of interaction that's more focused, you can do with a small vocabulary and looks to be achievable with a general language-independent speech recognizer. All right, so I will basically just show you one picture of interesting research that came up. This is from Madeline Plauchet, who did the work. How do you actually collect data to learn how to recognize speech from illiterate speakers? This has never been studied before. The normal way you do training for speech recognition is you have people read the word out loud. But if they can't read the word out loud. And you can't tell them the word verbally, because then they'll mimic what you said, which is not what you want either. You want them to say it how they would naturally say it. You also notice, if you look closely, that she's speaking into a phone instead of a microphone. Why is that? Well, in my mind, that's at least in part because it's more comfortable for the speaker. Microphones are a little bit scary, whereas the phone is a little bit more friendly. And again, you don't want to disturb the natural speech pattern. Why are there Indians doing the questioning? Because they're locals and they're more comforting. Right? So there's a lot of issues in this picture alone of how do you get speech recognition to work for unusual language, particularly for illiterate speakers. This is a typical application window. I won't go through it, but basically this is a way to get information about agricultural crops and techniques using a spoken interface. And you can read the words, but if you don't read the words, you can use the pictures, or you can listen. It plays sounds that describe, and then you say the word that goes with the picture to actually do selection. So it'll highlight, the middle box is highlighted because that one's been selected. So we're building applications that allow you to interact with the computer using entirely this speech recognition. All right, so we have actually 3 posters today, 2 on education and 1 on the telemedicine. And I'll stop here. The website at the bottom is the best place for ongoing information, and that leaves me 3 minutes for questions and getting us back on schedule.
So we do have time for questions, and again we have people with microphones. Steve.
Very impressive. You showed an interesting photograph of a tower, vertical, with the Linux router, Wi-Fi, and the antenna.
Right.
What's the lifetime that's been up? What kind of environmental impacts? Rain, sun?
So far, our longest ones have only been up maybe a year or 2. So I don't think we have a full answer. I can say the very first enclosure we did was a plastic box that we got locally, and it disintegrated in 6 months. In fact, the router broke, and we didn't know why until we actually went there and realized that the board had been fried due to water, which came in because the box had disintegrated. So there's actually a big need for all kinds of solutions on enclosures and lighting and mechanical engineering, broadly speaking.
Great opportunity. Thank you.
In fact, there's needs. I have a long list of needs in many fields. I heard there's a question over there, but I don't see it.
On your last graphic that you showed with the voice recognition research being done on agricultural processes and the like, where is that being done?
That's in Tamil Nadu, and the language is Tamil. And but again, we have another piece of work that's actually quite related, which is kind of like a speak and spell game, if people remember speak and spell, where within 1 hour you can create this learning game for any language that, you know, a non-IT person can convert the game to work for their language in about an hour. So it is in Tamil, but there's nothing about Tamil that we're exploiting in that application. So it should work for any language.
Madeline Cochet is here.
Madeline might be here. I can't see with the lights on.
Here in the sense she's in Berkeley.
She's in Berkeley, but she also might be here today. But if she's not, I'm certainly should be happy to talk to anyone about the particular applications. But right now it's in Tamil Nadu using the Tamil language. It was right there.
For the CITRIS buildings, are you going for LEED certification, and are you able to use the buildings themselves as test beds?
I think you're talking to him, which is fine.
Here.
We're going to use it because we're going to put antennas on top of it, but that's probably not what you're asking.
In terms of the energy efficiency element, it isn't going to be quite up to that standard. The better person to ask maybe is Dean Jeff Wright, who at Merced the buildings there are LEED buildings.
So the answer is, I think that perhaps at Berkeley we'll be doing a few things. I think things like tier and putting antennas and all that is easy. But Jeff Wright, who's here as the Dean of Engineering from Merced,
all of our buildings are LEED certified. And
All of the UC Merced buildings are LEED certified silver, and we're hoping for one at a higher LEED certification soon. That's a great answer.
Just a simple question. Where do you see the application for more developed countries in the improvement of healthcare?
Actually, one of the things, too, so I've given the telemedicine talk in more detail to a couple groups in the U.S. The two that have the most traction, we'll see where they go, is Indian Health Services, which is the group of the agency of the federal government responsible for health care on Indian reservations. They already do some telemedicine, but they don't really have good connectivity choices. They use very expensive satellite connectivity right now, and we have a chance, because of the distances we can cover, to greatly reduce their costs. The other one that's had some traction is the state of Virginia, I guess the Commonwealth of Virginia, has a telemedicine program in place. Southern Virginia is relatively rural. If you know West Virginia, it's pretty similar to Southern Virginia, and they border each other. They would like to extend their existing rural telemedicine program to actually be more rural than it is, because they don't have a good way, again, to get high bandwidth video quality connectivity to a lot of the rural parts of the state. So we may do a pilot with them also. I think broadly speaking, there is no good global solution for rural connectivity in any country. This is the best I know of. It would make sense to try it in the U.S. as well. But less necessary in the U.S. because of satellite. Satellite works in rural areas. It's just very expensive. It's too expensive for developing countries.
Hi, quick question about working with the NGOs in India to understand the ground realities. What are the filters you're using to select the NGOs you're working with? That's number one. And secondly, I mean, there are lots of complexities even in the bottom of the pyramid. I mean, it's made out to be a uniform thing, but there are lots of complexities there. So how do you get to understand that, even for the education game, depending on which sector?
So that's a great question. There's a lot of complicated answers. So first let me just say that the general notion of the bottom of the pyramid is that it's homogeneous, which is completely ridiculous. In fact, I think really the entire thought process at the bottom of the pyramid is flawed because of its assumption of homogeneity. It's really misleading for that reason. That being said, what we end up doing is, of course, is individual projects with individual NGOs and individual locations. And that's the only way to do them, and of course, all those are by definition localized. Answering your broader question of how do we pick NGOs, it's not easy. I think we're good at it now. We weren't good at it first, but we actually had a few students, again, some of whom might be here, that interviewed, I believe, 80 different groups in our first year partially to figure out what kind of good projects there were to do, but also to figure out how do you find good partners. The good news is there are many NGOs throughout the world that have long public track records with relatively high transparency, not because of any local things, but because they tend to get funding from international groups that require some transparency. So you can find good NGOs, as far as I can tell, in every country if you look. And of course, you have to pick projects that align with their mission, or they won't really support it for very long. Right? You can't make them stretch into some new area. That's kind of a problem because there aren't really many technology-savvy NGOs. So you have to pick ones that want to be technology-savvy and help them get there. But if they don't want it, you can't fix it. Right?
Can you talk a little bit about what you're doing in Africa? I know you talked a lot.
We are doing a couple different things in Africa. The most work we've done so far has been in Ghana. We're looking at healthcare in Ghana, including telemedicine, but also actually using cell phones as the rural device for nurses. It turns out that you'd actually like to have data collection capabilities for disease detection, even for basic things like why do kids die? It's not typically known. And if you don't know why kids die, you can't correctly allocate resources. So in fact, in Tanzania, there was a study where all they did was collect reasonably good surveys of why kids were dying. They changed the allocation of resources and reduced the child mortality rate from 16% to 9%. So that's a 40% reduction over a 5-year period. Right? So there's lots of room for cell phones, I think, as portable computers, essentially, not as communications devices. That's wide open. We'll be trying that in Africa. And also, I think we're in the middle of trying to find a quite large project with the government of Rwanda. Rwanda is a nice country to work with for a couple reasons, but one is it's small, and it is possible to do national projects in Rwanda because it's small. And also the particular government, people think of it as a violent place. It's actually an amazingly safe place at the moment, a good place to send graduate students, and has essentially a benevolent dictator that makes it a pretty good place to get things done. Right. It's not a democracy, although they have elections scheduled in 2010. We'll see if they happen. They probably will happen in some form. But ignoring the dictatorship part, it's quite a solid, efficient, well-run country, and believes that IT is its future path. And so we'll see where that goes.
All right. If there are no more questions, I'd like to do just one more thing as in closing. So I'd like to. I'm mic'd up. I'd like to propose that I understood that Rich Newton is perhaps watching this on the computer. It's being webcast and so on and so forth. So I propose that we give a really wonderful round of applause for Rich to having gotten us all on this wonderful journey, and to thank him for having gotten us here so far. So let's declare Rich.